So as we walk by, I'll just want to introduce my colleagues, Ryan Hodina, Greg Jones-Henry, and Jim Lynch. So we'll all be involved in various parts of today's live demo. And I think I saw a number, we're up to about 58 people watching. So, 63 I see. So that's great. We got great turnout here today. So this we'll do is a quick walk around the system. So this is the Gerber MCT cutter. Again, you're looking at the 3.2 meter by 3.2 meter system, or 10 foot by 10 foot table. And I just want to point out a couple of key areas of the MCT cutter, and then we'll actually go through some cutting. So this is the user interface console. So this is provided with the system. Obviously, it's a user workstation, keyboard, computer. There's actually some nice accessories where you can put the various knife tools that aren't in use right now to be mounted here. Mouse, joystick, on, off, start, emergency stop. This is the screen for Tiger Vision software. Tiger Vision is really the heart of the system. That's what you're going to be using for bringing in files and also for assigning tool paths. So you can set the various speeds and feeds for the system that you're working with. And then we have a very extensive library of materials within Tiger Vision. So if you need to cut coroplast and you want to cut that with an oscillating knife, and you might have, 20 millimeter coroplast or sign foam, all of that is going to be stored in Tiger Vision in the materials library. So you don't have to figure out the speeds and feeds each time. That's all built right into our software, and it's a library we continue to add to. So that makes using the MCT cutter very, very easy and very efficient for especially for new learners. Now we'll move over and take a look at really the cutting area of the system. And this is the main cutting area. And from right to left, this is position 1, position 2, and this is the heavy duty station. So in position 1 or position 2, these are basically universal areas. You could put any one of 10 or 11 different cutting tools into position 1 or position 2. It's all modular. Right now we have a bevel tool that will be used to, this is used for cutting displays, for example. Excuse me. You can put, right now we have this set up to a 45-degree angle, and there's 5 different positions. You can change this bevel tool to set it to whatever angle you need to. This is the oscillating electric knife. This is going to be a real key cutting tool used for many of your thicker materials, fluted materials, for example. We'll use this today as well. Now, this station is where the digital camera lives. This is included with every system, and the purpose of this digital camera is primarily to read print-to-cut graphics. So when you're doing print-to-cut registration, the printer will print these registration dots, and then the camera will pick up the registration dots, and you get very good, clean print-to-cut registration. The camera can also be used to read QR codes. So if you're sending jobs in via QR codes, the camera will pick up the QR code. And you can also use, if you're working with a non-printed material, the camera will be used to do an edge detect. So if you're trying to register a material that's not printed, we can use the camera to register the edges of the material. So you get a nice accurate cut. And now this station here is the heavy duty station. So right now we have our 100-watt laser hooked up into the heavy duty station. And this is how the system could be configured right now for cutting. And if you decide to use the router, and we'll show you that laser later, we will take the laser off, put the router on, and these other tools can stay here, or you could put in some other tools in these stations. And we'll be doing that during the live demos. While I'm here, I want to point out one other item. This is, it's called an auto touch-off tool. That's what this device is here. This is a sensor. So as you put in a new tool, that's going to take care of how far a router bit or a knife tool might be sticking out of its collet. And that's the purpose of this sensor. So we're going to bring the tool over, take a reading, and we'll know exactly the Z-axis position of the tool. relative to the call it's sitting in. So that's part of our system. That's the auto touch off tool. I'm going to walk over this way a little bit. And what you're looking at is the silver, actually, this is the dual laser belt, it's called. And this is an integral part of the success of our system. It's actually two belts. The top belt is an aluminum belt, and that's what you'll use when you're using the laser. And underneath the aluminum belt is a gray, it's actually a needled polyester is the material. We call it a gray felt belt. So the dual belt is going to allow you to quickly change over from laser cutting, for example, to knife cutting and router cutting. And the key to that is the operation of this belt. It's connected via a zipper, and there's 8 individual panels. So you can put the belt on, and when you need to remove the actual belt, you unzipper, and we're going to demonstrate that later on. Take the aluminum belt off. It goes in this cart over here. It will show you shortly. So the aluminum belt stores on here. Then you've got the gray belt underneath, and you'd use that for your routing and your knife cutting. I always like to encourage people to look under the hood, and you see some interesting things on the MCT cutter and see how well built it is. So you're looking at a 20 horsepower vacuum pump underneath the table, very powerful vacuum pump. You're looking at steel cross beams, a steel frame, and aluminum extrusion. So it's a very solid, heavy based system. Very sturdy structure. Now, while we're here, I want to point out the helical racks that we use on the MCT cutter. And a lot of drive systems do use a rack and pinion drive, as we do here. But many drive systems use a 90-degree rack and pinion. So a 90-degree, the gears that are traveling are in a 90-degree position relative to the rack. We actually use an angled rack, and that allows you to get much, much better precision, much better control, especially at the high velocities and high accelerations that we're traveling. So that's an integral part of the success of the MCT system, a helical rack in the long direction. And we also have a helical rack on the gantry right here. One of the other items we use on the MCT cutter is we use dual motors. So we have a drive motor on this gantry and a drive motor on the other side as well. It's under this cover, but this is driven on both sides. Other systems use just one drive motor, and they'll have a slave on the other side, basically no motor. So a single motor is controlling the drive mechanism, where with MCT, we are using a dual motor system. Let's walk back here a little bit. So the dual laser belt, if you have the dual system, you're going to see 2 rollers here. So we're controlling the laser belts with this roller system, and we're controlling the gray belts with this roller system. So that gives our customers a lot of flexibility. Sometimes a customer may want to start with a knife cutting system or maybe a router system, and they'll have this belt here, this roller system here, and then later on, if they want to add the laser system, very easy. We've got a kit. We can add the dual belt. We can add the laser system, and then we'll add a few other things that I'll walk around and show you. This is an optional item we use for folks that are doing high volume flexible goods. This is an automated roll feeder. And with this, you've got several tension adjustments here. You've got a dancer bar, so you can keep your material nice and taut. You can adjust the setting, so it's going to go through exactly what you want it to. Put it on the conveyor, turn the vacuum on, and that'll advance the material, and you can cut very, very high volumes of flexible, soft materials that way. So now we're at actually, this is the feed side of the table, and this is termed the datum side or the reference side. And what you're looking at is a couple of items that are related to whether or not you have a laser or a router, or both. So if a customer orders a laser or router, we use a liquid cooling system. So this is a chiller. This is built right into the panel for the system, and we're providing cooling cooling liquid from here to the laser head or to the router. So it's a closed loop system. It has a sight gauge on it, makes it real simple for our customers to keep the high powered laser or the router cool while it's running. And with the laser, you can see this device up here is called a festoon. That's the black apparatus with the hoses on it. And the purpose of that is to bring hoses from the cutting head in the case of the laser over to the fume extraction system. So the purpose of the fume extraction is when you're using a laser, you don't have to worry about venting anything outside. The smoke from the laser comes through these hoses over the festoon and into the purification system. It's a two-stage purification system, top and bottom. There's changeable filters inside, and there's a display on the top that tells you the status of the filters. Now, if you have a router, you're still going to use the festoon. You're going to use a different set of hoses, and then we'll bring the debris from the router into just a dust collection system. So this is part of our router-based system. So whether you get laser or router, you're going to get the festoon. And in the case of a laser, you'll have the purification system. In the case of the router, you'll get the dust collection system. And in both cases, you'll get the liquid cooling system. And that brings us back around to the front, and we can actually start doing some cutting. So I think, Greg, you want to show the capability of the laser?
Certainly.
Okay.
So let me move this out of the way for a second. So as Mark mentioned a couple minutes ago, we're going to do a cut with the laser, and we're also going to go ahead and use the camera for the registration part of it. So that'll make sure that the laser cut is going to be matched up, in this case with the printed graphics, correctly. So you can see here we've got black registration dots around each one of our cuts. So the system is going to go ahead and use the camera and find the dots for each cut. Go ahead and make that cut, and then move on to the next one. So what I'm going to do to get that started, and yeah, so the vacuum's going to turn on in a minute. So I'm not sure if you're going to be able to hear me with the vacuum on. I'll still speak, but if you don't hear me, we can go ahead and kind of, cover it afterwards as well. Maybe showing the screen here for a second, Ryan. So this is the image from the camera, and here's that first registration dot that is picking up. The purple and blue, circle here indicates that it found that registration dot correctly. I'm just going to center it a little bit closer to the middle of the crosshairs there for this first one. There we go. And we're going to tell it on the image out on the right here which one of these dots we're starting at. So we're starting in the lower left corner here. And then we click the green button. And the system's going to go ahead and it's going to find those registration marks on this job. Now that found the registration marks, it's now going to go ahead and use the laser and cut out those 5 rectangles. So of course, with the hood in place, you're not able to really see the laser. If we were to squat down, we could see a little bit of the laser beam. But in general, it's a good idea to not look directly at the laser beam. And of course, the purpose of the hood is to evacuate any of the smoke or fumes that the laser is causing. All right, let's see how that. So there's our pieces that were cut out. And in this case, the actual print itself, we had about 1/8 of an inch or so bleed on purpose. That's why the You might notice a little bit of graphics still left on the scrap. That was by design. And there, in a nutshell, that's showcasing both the registration with the camera and also the laser cutting.
And one of the keys to laser cutting is a nice, for fabric in particular, a nice sealed edge, no stringers, no hangers, very, very clean cutting. For those that are looking at a sewing operation downstream, it's going to make the sewing process much, much more efficient to have a nice clean edge like that.
So yeah, so as Mark said, of course, some materials you absolutely need to have a sealed edge. So whether if you're doing like, hand cutting, you'd be using some kind of a hot knife. But for automated cutting, the primary tool is to use a laser. Beautiful thing with the laser is there's no mechanical blade or tool, in contact with the material. So there's no chance of you pushing the material or, miscutting a thread or a fiber or anything like that. It's going to almost always give you a very, very good quality cut. So let me pull these off. And next, we're going to do a laser cut in 1/2 inch acrylic.
So this is an application that to be able to use a laser to cut acrylic, it's probably not as fast as using the router, but I think what you'll see is the edge quality is amazing. I've been working with routers for many, many years, and when we first started using the MCT laser, just to be able to see the edge quality is impressive. So again, we're just putting, in this case, since we're using acrylic, we just put a little bit of a zone, a little bit of a gap between the laser belt and the acrylic for cutting.
Yeah, exactly. So normally with fabrics, we're going to go ahead and anything that's coming off of a roll, we'll just cut it directly on the laser belt. But with something that's kind of stiff, that comes in sheets like the acrylic, you could cut it directly on the belt. There's no reason why you couldn't, but we tend to get a little bit better quality results, especially in the bottom edge of the cut if we actually raise it up off the cutting surface a little bit. So that's up, again, about 1/2 inch above the cutting surface. And we're going to go ahead and cut a 2-inch circle. So let me go ahead and bring the beam over. We're going to line up I'm not sure if you can see it on the image there, but a red laser diode. It's right in this area here, if you can see it. We're going to line that up to represent our lower left start point. And we're going to go ahead and cut it. And there's our piece right there. I'm not sure if you can see the edge quality that well here, but it gives you a very, very nice smooth edge, both top and bottom.
And obviously that's right off of the table. There's no polishing required. Very, very impressive.
Right. Move that off.
Thank you, Greg.
Yep.
And obviously we use the laser to cut these as well. So
Yeah, use the laser to cut my spacers.
okay, so the next item we were going to do is the actual demo of taking the laser belt off, I believe. So you can see there's several zipper sections in the laser belt. I think there's a total of 8 sections. Most of them are, I think it's 1.8 meters in sectional size. And there's a steel zipper here it comes now. So that's what we're looking for. The steel zipper is used to just separate the belt. And the other sectional pieces, you can see a zipper here as well. And these are just pinned together. So there's only one section that gets unzippered, makes it real easy. And then if for whatever reason, if one of these panels gets damaged, you don't have to worry about replacing the entire laser belt. You can just replace one of these individual 8 panels just by unpinning. So that makes it very, reduces the cost of ownership for the laser belt. So we use the system to do the work for us. We're gonna use the conveyor and just put some tape and this cart that's included with the system.
Good stuff.
And you know that's it's that simple. Whoop. And let's see, this is a 3.2 long table, 3.2 meter long table. So that's 6.4 meters of conveyor belt. So that's about what, about 18, 20 feet of laser belt being rolled on there. And that's it. So now we're get that out of the way and we can now begin knife cutting. We could start knife cutting right now if we wanted to, or we can put the router on and we can start routing. And then obviously the reverse process, when you're in this state and you want to put the laser belt on, it's just undoing the process we just saw. You take the card over, put a piece of tape on, tape the laser belt to the gray belt, and then just go in the opposite direction and you'd have the laser belt on.
So for the laser removal, it's pretty simple. We've got one power cord in the back here, and we've got 2 coolant lines.
So those are the coolant lines coming from the chiller to cool the laser.
And we've got one compressor. And then it's just simply, we have the hose at the top. Then it's just simply 3 bolts, and that's it.
So now Jim's putting the router on. It's a similar mounting arrangement. You've got cooling lines coming into the router from the chiller. Yep. So this is a 2.5 kilowatt router.
The other thing we're going to do is move
our lines from the fume extractor to dust collection.
So at the bottom, when we had the laser, we were taking the hose and going into the fume extractor. Now we're changing that and going into the dust collection system. So we're going to start with knife cutting. And right now we're going to show the basically a display application. We're going to use the oscillating knife to cut the perimeter. And then we're going to use the bevel tool to cut a 45-degree angle so you can fold material like you would for a POP, POS display.
So typically we do a tool touch off right now, but since we've already been using this oscillating blade, the bevel knife, we've already done our tool touch offs on that. So we're just going to come straight over here and
So that's the electric oscillating knife tool that's running right now, and that'll be used for most of your thicker materials. And now we're using the bevel cut tool. We're using that to cut a channel in the material, so you could fold that. Cuts a channel in one direction, then it cuts a channel in the other direction, like a V. So the application for this, again, is displays, POP work, POS work. Many different materials, substrates, coroplast, paperboard corrugated. There you go. Thank you, Jim.
for our next trick, we're going to switch straight off to the route.
Okay, very good. I'll do that. So what Jim was saying was when you're routing, some people do route directly onto the gray felt mat, but this is a material called Guru Grip, and it just is it's a nice material for holding routed pieces in place. It's porous, so the air passes right through it. Most of our customers do like to use that as an option. And one thing I'll point out is just note as the machine moves around how quickly the acceleration and deceleration is going from point A to point B. It's actually quite amazing. Keep an eye on that as things are being moved around. Is that better from a sound perspective, Corey?
Yeah, thumbs up.
Okay.
Do a little router warm up right here.
Okay. So Jim is doing, we didn't have the router on, and as is with any routing system, you want to do a router warm up. So that's all automated. Jim starts the router warm up, and it just brings the bearings up to temperature before we start actually routing. So the material we have on the table is dye bond. I don't know how thick it is, maybe 3/16 of an inch or so.
Now we're doing the tool touch off.
So that's going to initialize the router bit tip on the ATT. So now we know exactly how far the router bit is sticking out. And the motion of the gantry, that's what I'm talking about, how quickly the machine accelerates back and forth. And because of the helical racks that we talked about earlier, that enables us to control the system very, very well. So obviously that's a little bit louder. I'm going to take this off of my phone so you can hear it. Corey, you want to spotlight Ryan's? Corey, spotlight Ryan. There we go.
So most of the roughness that you see there is just the adhesive poly in the top and bottom. That never cuts smooth. So we can peel that off. And the actual edge is pretty decent.
So that's router capability with die bond, or any material that's got an aluminum skin, plastic core. The router is a 2.5 kilowatt router, and it's running at 60,000 RPM. So it gives you an awful lot of capabilities for cutting die bond and rigid materials. The clearance in the Z-axis, you can pretty much cut 2-inch material. Obviously, it's a function of the router bit and the thickness, but this gap right here is just about 2 3/4 inches, I recall. So you can get some pretty good material under there.
Advancing the conveyor belt to get a little bit of that debris out of the way. And next up, we're going to do a tool change. And with the driven tool, the DRT in position. And put the
So the driven rotary tool and the electric oscillating knife are both motor driven. So you can see a small little electric motor on the top of that, on the driven rotary tool. So that's a rotary cutter that's motorized. And Jim's also going to take out the bevel tool. We don't need that in there at the moment. We could put in another tool if we wanted, if we had a job that had, for example, the driven rotary tool, and we wanted to put a tangential knife in here or a pen. We've got options to do that, or the punch tool.
Yeah.
Yep, we can put the punch tool in there as well. That's actually going to be our next demo. We'll show how the punch tool works.
Speaker phone all the way up so that you can hear Corey without your headphones.
That's a good point. I didn't think about that.
Yeah.
There we go.
Now,
Okay.
now turn it up. That's how you'll hear him. We'll just point the mic wherever so people can hear.
So we're initializing the punch tool with the ATT, the auto touch off tool.
Then we're also going to go ahead and do the same thing for the driven wheel.
And that sound you're hearing is the motorized driven wheel. Now we're going to initialize that as well.
Hey, Mark, what is the material you're about to cut?
So this is a foam material we're going to use to demonstrate the punch tool. It's got some thickness to it, and just wanted to show the capability of the punch tool. The punch tool has a variety of common size diameters. I don't know what this is. Looks like it might be about a 1/4 inch diameter. But you can go all the way up to just about a 1/2 inch and down to, I believe, about an 1/8 of an inch. Or so many different size common punch tools that could be used to literally punch out round holes versus cutting them with a knife. So the punch tool is something that Gerber uses on the industrial part of our business, and we adapted this capability to the MCT cutter to make it better for our customers, just to be more efficient when they need to cut a whole bunch of round holes in various sizes. So that's just a much more efficient process if you've got a whole bunch of circular holes you need to produce. Using the punch tool fits right into the universal tool body, so you can put that in either position 2 or position 3. Make it very, very simple for our customers to use. So the next demonstration will be using the driven rotary wheel, DRT. And this is a wheel type cutter with, there are other wheel type cutters that are non-motorized. This is a motorized cutter, so you're going to get better performance with this. And it cuts a variety of materials. This is a foam material, but you can use the DRT together with the laser is a great combination for being able to produce materials where if something does have, someone asked a question about the laser earlier, if you have PVC in a material, you don't want to laser cut it. Chances are very high you can probably cut that same material with the driven rotary tool and get very good results.
Here we go.
So a nice clean cut.
Let me see it better.
So that's all the live demos. While we're here, I just wanted to spend a minute and show some of the other samples we have that we've used the MCT cutter to produce. And this box is no exception. This box was actually cut with the oscillating tool and creased with the MCT creasing tools. So we can use the MCT cutter obviously to produce boxes for the packaging market. The driven rotary tool you just saw a minute ago, that in that foam material, that file is actually a PPE mask. So we produced these PPE masks, and we have many customers that are using the MCT cutter right now to produce PPE masks. When we produce these, we use both the laser and the driven rotary tool to produce this PPE mask, and it came out very nice. Just a couple of other samples I have in here. We've used the router and the laser to cut through wood. This is laser cut with engrave on the top. This is also laser cut. So just some examples of using the laser to cut through thin pieces of wood. And these pieces of acrylic are also laser cut. And again, you can see the really nice edge quality, nice and clean. And you can use the laser to cut through, or if you just want to etch on the top, as was done here, that's actually etched with the laser, and you get a really nice effect in acrylic or in plastic. These are just some examples. We had a customer in the furniture business that they needed to cut some fabric material. So all of this material was laser cut. Very, very easy to use the laser for a variety of materials. So 80 millimeters per second. And one of the big benefits, this is something I like to show. This is also laser cut. And we mentioned this a little bit earlier. When you're using the laser, you're not using a mechanical process while you're cutting. You're using light. So you can get really, really close and cut materials that you're not going to move the material around while you're cutting. It's non-contact cutting. I mean, just to give you a sense of scale, that's very, very close, nice, clean cut. Parts aren't moving around. So it gives our customers an awful lot of capability to be able to use the laser. So, you know, I always recommend if you can laser cut something, that's a good way to go. And then if you can't laser cut it because of the content of PVC or something like that, the driven rotary tool is an excellent combination. And here's one other example. This is actually a laser cut bag. When we were having trade shows, we were actually making these at a trade show. But it's not the greatest practicality of a bag, but it's pretty much shows the capability to be able to make something really detailed. Again, laser cut. And if you tried to do that with a mechanical process, you just simply couldn't. There's no way you could cut something so close together. So if you've got expensive material that you need high yield on, a laser is a great option to be able to do that. So that is pretty much everything we wanted to cover. We can open it up to any questions anybody has.